We are going to begin a new unit now entitled Covariates. And I want to begin this unit by giving you some definitions, some conventions, even some problem areas in terms of those definitions, some symbolism, basically lay the framework for our discussion so that we are on the same page in terms of how we are defining various terms. So let's begin with the actual term covariate. What does that mean? Well, I'm going to start by actually referencing how we might diagram a variable. I will typically diagram it with a box. So this is a box, and this could represent a variable. If it's the response variable, I'll typically use the symbol Y for the response variable, or if I know actually what the response variable is, I might indicate what the response variable is in that box. And then we have variables such as an explanatory variable. Let's call this explanatory variable x1. Since we've been dealing with multiple regression, we know that we may have more than one explanatory variable. So we might have another variable called x2. And then the other part of the symbolism that I want to talk about is the fact that we could indicate relationships among these variables. If I'm indicating that one variable is either the cause or the presumed cause of a variable, such as x1 being the presumed cause of y, that is, changes in x1 will result in changes of y, I would draw it like this. I could also indicate that x2 might be responsible for changes in y. So either one or both of these x variables I might think of as influencing y. I also might indicate a relationship that's not necessarily a causal relationship, but simply a covariation, as it were, by presenting a little curve like this to indicate covariation. All right, so now we have a little bit of symbolism here, and you might notice the term covariation, and you think, wait a minute, you were just talking about this being about covariates, and so does that have anything to do with that covariation? Yes, it does. So the first thing with covariates that we're going to need is that we're going to have at least two variables that covary, meaning they're correlated together. As one changes, the other changes. Not necessarily a cause, but as one changes, another changes. And so they're correlated, or they covary. And so a covariate, in a broad sense, simply means that two variables covary, or they are correlated. Now, not everyone uses the term in that broad sense, including me. And so let's talk about the various ways people might use the term. And if this seems confusing to you, I will tell you that the world is somewhat confused about this. All of us are, because we're using it in different ways. So I would recommend anytime you are talking with someone about a covariate, you might want to make sure you understand how they're using the term. There is no statistics king that is saying to us, this is the way it should be used. And therefore, if individuals go off and define it in different ways, they are left free to their own devices. So we need to decide how we're going to think of a covariate. So in the broad term, I've already indicated one possible definition, and that is variables that are correlated or covary. So that's the broad definition. A little bit more specific definition is quantitative variables that covary. Now, why would we do that? Well, if you have quantitative variables that covary and call them covariates, then what do you call the categorical variables that covary? Those are typically called, we'll put this down here in brackets, categorical variables that covary are often called factors. Then a third way that you will hear people use the term covariates is that a covariate is a quantitative variable that covaries with the response variable, but it is not the variable of primary interest. It is a variable that perhaps is an extraneous variable or a variable that you're trying to control for in a study. So this narrows it down even further. So the covariate is not of primary interest, but does covary with the variables that are. So if we go back to my little diagram up here, let's go ahead and look at how this could be. So let's start again with this. Let's suppose that our primary interest is knowing the relationship of x1 to y, but we also know that x2 may be related to y somehow. It may be related to x1, and so we might want to include it in the study, or at least recognize that it could be influencing what's going on in the study. So some people would say x2 is the covariate, x1 is your explanatory variable. All right, the way I'm going to use this is this second one. I am going to refer to covariates as quantitative variables that covary. So I'm not distinguishing between a variable that is my explanatory variable or one that I am controlling for in my study, but rather I will say if a variable is also an explanatory variable. So I could have an explanatory or independent variable that is a covariate. I could have an extraneous variable that I'm including in my study that is also a covariate. So I really reference this as a quantitative variable. Now you might wonder why I choose this way. Part of the reason is because I am teaching you this in the context of R, and R distinguishes between factors and non-factors, that is, quantitative variables, which I would call covariates. So with that in mind, let's talk about a couple other definitions. Let me go ahead and draw a little diagram that has some covariates in it that has to do with the previous video series that you have hopefully watched before you came to this one, and that had to do with the basics of multiple regression. And so in that particular video, I actually constructed a report, and in that report, my response variable was the number of physicians in a city, a small city, and then we were trying to predict the number of physicians in a city. And so we had a couple covariates with y. We had our first covariate was the number of hospital beds in the city, and the second covariate was the income level of residents in the city. And we ended up with a model in which we thought both of these variables could be influencing Y, the number of physicians, and we also recognized that there was a correlation among the hospital beds and income as well. We initially began thinking about the possibility of density, but it turned out that density wasn't much of a covariate. That is, density seemed to be not really related to either the hospital beds or the income or physicians, and so we ended up not using density in our model. So I'm diagramming for you what we did in the last video series in my report that I created. Another piece of terminology here is that when we're talking about multiple regression, it is common to refer to regressing the response variable on the explanatory variables. Regressing the response variable on the explanatory variables. So in this case, we regressed the number of physicians on the number of hospital beds and the income. Now, if you're asking me why do we say that we regress the response variable on the explanatory variables, I have seen multiple explanations for that, none of which is very obvious or satisfying. And so I'm just going to say we do it. And that is just a terminology that you will go ahead and accept and use and need to know, because you'll hear people saying it. You'll hear people talking about regressing the response variable on the explanatory variables. Another thing that I'll point out here while we're talking about this model is that we ended up having error or residual. What is that? Well, that is variation in Y that is not accounted for by either, in this case, X1 or X2. So we could have some other kind of little symbol if we wanted to for our error that basically refers to, notice this is not a variable, so I'm not putting it in a box, but rather there are things going on outside the study, other variables, error of measurement, and so forth, that also influence the variation in Y. So all these things taken together, the variables that we used in our study as explanatory covariates and the error, all taken together, is what as would be summed up in order to talk about the total variation of the number of physicians across small cities. So we have what is in our model over here, and we have here what is not in our model, and that leads to residual variation. When we are talking about science, we are talking about cause. And we want to know if one variable, when it changes, is causing a change in another variable. But we know that variables could be associated without one variable causing a change in another. And so the fact that two variables covary doesn't necessarily mean that one variable is creating cause in the other variable. So we have some ideas that we have to consider to demonstrate a cause and an effect, and it requires three elements. The first is temporal precedence. What does temporal precedence mean? Temporal precedence is just a fancy way of saying that the cause precedes the effect. So if I have an X and I'm wanting to determine that that X is influencing Y, the variation in X comes before the variation in Y. That should be logical to you that if the variation in Y comes first, that cannot be the case that X is causing variation in Y. So temporal precedence simply means the change in X must precede the change in Y. We also need an association of explanatory and response variables. So using our diagram here, what we need before we can draw that causal line is we need to know that there is a variation, a covariation of x and y. So if you think of this curved line as being covariation, you can think of our desire is to take those curved lines and make them straight lines, because the straight line would indicate a cause. So we're wanting to take that covariation and be more specific about it, to say not only are these variables correlated, but changes in x cause changes in y. And then the third and final thing we need is the tough one: elimination of alternative explanations. So before I can say that changes in x are causing a change in y, I have to make sure that there's not another alternative explanation, of which there could be several. One, for instance, that we're going to look at very shortly is that there's this second variable out here that is actually influencing both x and y. And if that second variable is influencing x and y, then x and y are going to become correlated. They're going to covary, but x1 is not going to be responsible for cause, but rather x2 is responsible for causing and influencing a change in both x1 and y. And then we could have a variety of these kinds of things, a variety of variables that could be influencing x1 and y. We could have variables that go through other variables, and we'll be talking about that in a little bit. So we could end up having variables that maybe a variable that influences x1 and in so doing influences y, and maybe also directly influences y. So there's a variety of ways that variables can cause changes in other variables to mask the potential cause and effect, or make it seem like there is a cause and effect between x1 and y when maybe there's not really one there. In short, what I'm saying is that associations of explanatory and response variables are often due to other variables that may or may not be in the model. So one of the main concepts that we are exploring in this unit is, what are the various ways that you could have associations of explanatory and response variables in which it's not a causal association? And how do we look for those? How do we determine that that's the case? And that really is what we're going to do in this unit to add on to our understanding of multiple linear regression, thinking about the possibility of what kinds of relationships you can have among variables. That is, what kind of covariates might you have? So we'll continue with that and looking at our first possibility in the next video.